For our ME470 final project, we will be repairing this stone machine. What happens is a slab of stone is laid on the end on a turntable and it passes down through this conveyor belt. What happens then is it comes through this and there's a head that grinds the stone to size. Right now the only two buttons that work on this control panel are the raise and lower, so this will be the main focus of our project, is fixing this control panel so when I push lower, the head moves, as well as when I push raise. If you look up here, this is how the thickness is currently judged. It's with this tape measure and that wire, that's the thickness of the stone. You can tell that that's not super accurate, so we're going to add an electronic display. Over here there's another head. This isn't the main control box, so it will be controlled from over there, but these buttons also work. And we will just be implementing a device to control the head motors to move up and down from one location. Another current problem with this machine is that in order to control the conveyor belt, you can look over here, the control panels are back over that way, but to control the conveyor belt, the device is over there. So to turn on the conveyor belt, you actually have to climb up the machine and flip the switch in order to get the conveyor belt to move. And then once it moves, you can get down and run the heads. So what we want to do is move that control box over here, so that way we implement some safety and you don't have to cross over the machine. Okay, so this is our final product and what we've come up with. Over here we have the control panel, and if you remember from earlier, we had a couple things that weren't actually working. And we had these buttons that were raise and lower. We went ahead and kept the raise and lower button so that it can stay manual in case it needs to be adjusted just a little bit. We also implemented a new emergency stop button. The old one was pretty rough. And then the actual coding kind of comes in over here, and we have a keypad. And with the keypad, you just type in a number. And once you type it in, so right now it's at 4 inches if you look at the screen, and we'll move it to 5. And then you come over here to the trackpad and we'll just tell it to go to the desired. And this head just starts moving by itself. And so before you had to sit and hold the button, so this can save a lot of time if you have to move very far. As you can see, we're just moving an inch going up, and it's only moved a ½ inch since we started. So it moves pretty slow, and if you have to move it more than an inch, it can be a real pain to hold the button, so that'll save a lot of time. The other thing that we've done is we've added a calibrate to desired button, so that when the diamond segments wear down, this saw can always be recalibrated, and that way it'll be pretty accurate. Our overall goal for the project was to be within a 32nd of an inch for accuracy, and we set it to 5 inches, and here on the display you'll see that it's at 5.01, so that's less than a 32nd of an inch. So we feel like we've met that tolerance after some calibration. Other than that, we're going to now dig into the machine and kind of show off the parts that were used in the project. What we needed to use was a Raspberry Pi. That controls the graphical user interface that you saw on the screen. It also has the keypad input as well as the trackpad that go into it. And that also runs to a screen through an HDMI cable. And this is the motherboard over here for the screen, and that's what shows our graphical user interface as well. We also have established some serial communication, and that goes with the Arduino. In order to have that happen, what we had to do was actually thread the Raspberry Pi. So we split the processor so that half of it is dealing with the GUI and the other half is dealing with the serial communication. One of the issues that we ran into was that while we were having serial communication, the GUI wouldn't update and it would freeze up. So when we threaded it, it made it so that the GUI could keep up while we were still having serial communication. And that way you see a size as it's moving and you don't have to guess where you are. So this was programmed in Python. The Raspberry Pi was programmed in Python, and the Arduino was programmed in C, just in the Arduino IDE. and they communicate. The Arduino runs and listens to the rotary encoder, which is up here on a rack and pinion. So the whole head moves down, which causes the gear to spin on the rack, and that is sent down to the Arduino, which then sends the information over to the Raspberry Pi. We had to use the Arduino because the Raspberry Pi doesn't have pull-up resistors, so it would actually fry the Pi trying to communicate with the sensor itself. So it was necessary for us to have that serial communication. Some of the other things that we have going on is we'll have some wires, as you can tell, coming in over to go to the other head. The other thing that we have here is these wires come down and control two relays. One controls the up button, the other controls the down button. The idea that we had was to overlap this so that if anything goes wrong, the company won't be any worse off. They can still control the machine manually like they did before, and now they just have this added implementation to help them out and save them some time. So this is actually wired to control the button while the button can still work by itself. And here you can also see the emergency stop button that was just replaced with the previous wiring. Really the biggest issue that we had on this project, as you can tell, is there's a lot of red wires here. And this machine is from probably the 1970s or 1980s. And so we had to figure out what the circuit actually was. And we had to deal with those wires and still make it so that the machine worked and ran. And one of the things we did in order to save on some wire is we dug into the circuit, we figured it out, and as you can tell there's 20 red wires here. And then we actually put in an outlet box so that the Raspberry Pi can be contained inside of the control panel. And so that was probably one of the more difficult things we did, as well as trying to figure out the circuitry for all of the relay logic that they used back in the 70s and 80s. But overall it was a success, and we'll show you the one other thing we did with the conveyor belt to move it over. As you can see over here across this belt, we have a motor, and that motor controls the conveyor belt, as you've seen in our past segments. And the conveyor belt box used to be over there. We found out that the conveyor belt box actually ran 3-phase, which is 480 volts, and we didn't want to have to mess with an Arduino interfacing with that. So as we talked with the company, the decision we came up with in order to still achieve our objective was to move the whole box over. And so we dug into the box, unwired it, and rewired it with some 3-phase wire. And we've now moved it over here so that you don't have to climb across the belt or walk clear around the whole line in order to access the control. So you can see if we turn it on, it runs, and it's going to save a lot of time from them climbing over or running around, especially in a hurry.